Where is everybody, huh? Taking some time.
Like either because today in our school we don't have well technically we don't have school today online because the teachers are doing hunting. They may have confused it with this class. That can be a possibility.
Okay. You don't have school. Samueli doesn't have school today?
Yeah, the teachers are like getting together to make a plan so we can come back to school. So that's why there's no school today.
Okay.
Yeah, but like they told the school like there's no classes. Probably some people are like forgetting, so they'll probably have to be reminded later.
Okay.
Something like that.
Okay. Maybe maybe I should send out an email real quick. Say, hey, you know what? Come to class. Okay. Email sent.
Professor, I joined class late.
Okay, that's fine. I haven't taken attendance yet.
Oh, my bad.
It's okay. Thanks. Okay, Cassidy,
Here.
Alejandro,
Here.
Liliana, Lainey,
Here.
okay, Cassandra, Romeo,
Here.
Brenda, Jasmine? Josue?
Here.
Oh, Josue's here. Jade? No Jade. Valerie? Edsel?
Here.
Oh, Valerie's here. Valerie's just delayed. Okay. Joel?
I'm here.
I got you.
Here.
Thank you, Joel. Monique? No Monique. Salvador? No Salvador. Caitlin?
Here.
Kayla?
Here.
Romeo? Romeo Ramos?
Here.
Good. Paola Robles?
Here.
Okay, and Ricardo Vasquez.
Here.
Let me go over this one more time. I have no Liliana. I have no Cassandra. I have no Brenda. I have no Jasmine. I have no Jade. Say that again. I have no Monique. I have no Salvador. That looks like it's about it. Okay. If you're here and you're marked absent, please let me know. Okie dokie. Okay, so we're going to move into chapter 9 today. Oh, Cassandra's here and Brenda's here. Okay. Cassandra's here and Brenda's here. Okay. They just don't have a mic. Okay, so Brenda's here and Cassandra's here. Okay, good. Okay, perfect. So just Jasmine, Jade, Monique, and Salvador. Okay, perfect. And Liliana. Okay. Nice. Okay, so let's move into we're going to do chapter 9 and chapter 9. We finished chapter 8 last week. We're going to move into chapter 9. Next exam, I believe, is chapter 8 and 9. Okay, so our third exam is on chapters 8 and 9. Last exam will be on chapters 10 and 11. And we're supposed to have a final exam. I'm thinking about making the final exam a project. So we'll see. I may not make that a formal exam. I may make it a project. Kind of similar to what you did before with the car or the loan, but a little bit more involved because we're dealing with probability and statistics, and you know, expected value and normal curves and everything else that we'd be learning in the second half of the course. So that's kind of my tentative idea there, but yeah, chapters 8 and 9 exam coming up pretty quickly on October 28th. So less than 10 days. Okay, and I really want to see these exam scores go up with you guys. So that's what's killing a lot of your grades right now. Okay. Okay. So make sure that you're doing your homework too. Oh, and make sure you're turning in the worksheets. You know, I'm only getting about half the people turning in the worksheets every week, which again, that's killing your grade. So it's like free money, you know. You know, some of the problems I grade for accuracy, but most of them I just grade for completeness. Did you try the problems? And if you tried the problems, then you know, and you're on task. You know, you're not putting something down that's completely off the ball. You know, if you said, oh, well, this is, you know, categorical when it should have been qualitative, I'm like, okay, well, that's fine. They're at least answering the question. They may not have gotten that one right, but I'm still going to give them full credit because they attempted the problem and they were at least doing what they should do. You know, now on the last problem, I did grade that for accuracy. You know, when it's like, you know, if you're way off, you know, you're like, oh, well, it should be 600 when it should be 220 or something like that. So, you know, but for the most part, it's basically, you know, free points. And if you're not taking advantage of the free points, you know, I mean, this is college. This is a little higher level, you know, and I just am, I'm wary of what you thought college level material on a college class was going to look like. So just anyway, enough of the lecture. You know, it is what it is at this point, and the people who are going to take the class seriously are going to pass, and the people who don't take the class seriously, they're not going to pass. So, you know, they say the old adage is you can lead a horse to water, but you can't make it drink. And in us as professors, we say you can lead a person to college, but you can't make them think. So, you know, I can't make somebody pick up the pencil on Sunday night and do the work. That I cannot do for you. So I can show you how to do material. I can post my videos. I can give you all the resources in the world, but it really comes down to whether or not you have the personal drive or desire to pass the class. You know, whether or not you see value in this class, whether or not you see value in my education, you know, whether or not you see value in that in your future. But that is a personal determination, and there's nothing I can do about that. So, you know, it's a partnership. You know, I think that's one of the problems is that, you know, I taught high school for 11 years, and I kind of jumped ship when it became all about, you know, teachers failing their students, and it became less about personal responsibility on the student side. And you know, it was like, well, you know, why didn't this student succeed in your class? Well, you know, it must mean that you're a bad teacher, right? So blame the teacher on that, and yeah, no personal responsibility. So once again, you know, nobody's going to make you do your homework, you know, and if you are at this point, you know, 17, 18 years old, and you are expecting someone to hover over you the rest of your life and make sure that, you know, you do your dishes and you take out your trash and you do what you're supposed to be doing, you know, if you're doing your homework or, you know, passing your classes, you know, I feel sorry for your parents that are going to have to continue on this process long after that process should have been over. So, so yeah, so just something to think about, you know, where do you see yourself in 10 years? Do you see yourself as a dependent, or do you see yourself as independent? So, and an independent learner. Anyway, thank you for letting me ramble here. So let's get into today. I hope some of that meant something to you. And again, the people who are just knocking it out of the park, you know, getting 20s out of 20s on everything, you're obviously not the people that I'm talking to. You know, has basically split down. Half the class is doing exactly what they're supposed to be doing. Half the class is not. So we have the haves and the have-nots. And you know, if you're on that border, if you're riding that D right now, I would highly encourage you to rethink what you're doing in this class. Rethink, you know, how hard you want to work. Okay. Anyway, enough of the lecture. So. Okay. Okay, chapter 9 is statistics, okay? Describing data, okay? How are we going to describe data that we get, okay? So once data is collected from surveys or experiments, summarizing and presenting the data in a meaningful way, summarizing and presenting the data in a meaningful way is the next process. We'll discuss presenting data graphically and statistically. Categorical or qualitative data are data identified as categories. We learned that last week. Okay, this is categorical data, right? So that's like how many blue cars are there? You know, how many Hondas? How many people own Nike shoes? Those are categories. Okay, recall arithmetic operations cannot be calculated with categorical data. Basically, can you add, subtract, multiply, and divide Hondas? No, you can't really. You know, Hondas versus, you know, Toyotas. Can you divide a Honda by a Toyota? No, that doesn't make any sense. So, frequency tables. Let's talk about a frequency table. A frequency table is a table with 2 columns, sometimes 3. Okay, I'll just say it's 2 columns to start off with. One column lists the categories and the other lists the frequencies for each category, i.e. a tally of items that fit into each category. Relative frequencies are sometimes added as a 3rd column to present the proportion of one category compared to the proportions of another category. Okay, so let's see what happens when we
Professor, can we see like the work that you're doing?
Yeah, it's still on roll call.
I'm sorry. I thought I was sharing my screen.
Thank you.
Yeah, sorry. Thank you. Okay, so here's kind of what I was going over. Okay, so if you have the notes in front of you, which you should have, then that was just what I was reading off before. So, so we're going to go through what a frequency table is and what a relative frequency is. Okay, so it says a simple data set of colors is blue, blue. Okay, so we've got blue, blue. Change this guy to red. Okay, and I don't want Smurfy blue. I want dark navy blue. Okay, so we've got blue, blue, and then another blue, and then another blue. So how many blues is that? Oh, and another blue. So we got 5 blues, right? Okay, so this is going to be color. Oops, let me make this a little less thick. Okay, so we're going to go color. Okay, and then we're going to go amount, frequency. Frequency is frequency. Okay, frequency is the amount of colors in that one category. So if the color is blue, then the frequency or the amount of blues that I have is how many? How many blues do I have? Not everybody at once. Okay, thank you, Cassidy. Okay, so 5 blues. Okay, nice. Okay, what about the next color? Okay, green. So for green, again, I gotta tone this guy down a little. Okay, thank you again, Cassidy. Okay, green, okay, is 4 greens. Okay, and then what about the other one? What's this one? This one, the last one is red, right? Red. So, okay, red is, I think it's 5, actually, right? So 5, thank you, Lainey. Thank you, Edsel. Okay, so red, oops, again, tone that down a little. Move this over. Boom, there we go. Okay, so we want red here. red is 5. Okay, so now I'm going to do what's called the relative frequency. Relative frequency, which we can represent as a fraction or as a decimal or as a percentage. Okay, relative frequencies are always kind of like percentages. But if we add this up, we total this up, I get 5 plus 5 plus 4 is 14, right? And so a relative frequency is relative to the rest of the population. Well, there's 14 colors here listed. And so for blue, it's going to be 5 out of 14. If I were to calculate that on a calculator, I would get 5 divided by 14, which is this. And then I'm going to multiply that by 100. I'm going to multiply this by 100 to make it a percentage. So this is equal to 35.7%. Okay, rounding to the nearest tenth of a percent. Okay, let's try the green one here. This is going to be 4 out of 14, right? Which is going to equal what? Okay, 4 out of 14. Let's go back to our calculator. 4 divided by 14, okay, is going to be 28.6%. Okay, so 28.6%. And then what about red? Okay, red is going to be, oh, that's 5 out of 14 again. I know what that is. That is 35.7%. Okay, that's the relative frequency. Now, if I did this all correctly, my relative frequencies, they should all add up to what? Any ideas? What should all of those relative frequencies add up to? Because
100.
100%, exactly. Thank you so much. Yes, absolutely. Thank you, Alejandro. Okay. Thank you, Edsel. Thank you, Cassidy. Okay, yes, 100%. Okay, they should all add up to 100%, just like 14 out of 14 is 1, and so it's 100%. Okay, pretty cool. Nice. Okay, let's look at a bar graph. Okay, a bar graph displays rectangular bars for each category where the length of the bar indicates the frequency of that category. This is a horizontal, there is a horizontal and vertical axis. The horizontal axis lists the categories. Okay, so the horizontal axis is going to list the categories. Let's go to black here. Not that one. Why this thing reset every, I must have updated or something. Okay, so we've got a horizontal axis and we've got a vertical axis. Okay, horizontal, think horizon, right? Like the sun. Okay, sun sets on the horizon. Horizontal axis. Vertical, think of vertical blinds. I have vertical blinds here. See these? Okay, and then I got my little Star Wars sheet. My Star Wars bed sheets to keep the sun out too. There's my dude Kylo Ren here. So he keeps the sun out for me. So because it beats down in the afternoon, it beats down on my stuff. My window gets really hot. So I have an extra layer of protection there. So yeah, I'm a big Star Wars fan. Big, huge Star Wars fan. I went to downtown Disney this weekend with my daughter just so that we could buy some new lightsabers. So I got my lightsaber. It's all good. See, I got my new lightsaber. I'm a happy guy. So,
Here.
exactly. Exactly. Yes. So, I mean, again, I'm big Star Wars. I was a big Star Wars fan ever since I saw Return of the Jedi. So, you know, and I have some skills too with the saber here. And so does my daughter. She's very good. I've taught my Padawan well.
I see the forest. I see the forest.
Exactly. Although, there are two things we don't talk about in our house, though. And that one is the Star Wars Holiday Special. We don't ever talk about that in our house. It doesn't exist. And neither does Rise of Skywalker. That doesn't exist in our house either. So, yeah. Very sad. Very sad. What I think about Mandalorian, they killed it on Mandalorian. I'm so excited. I'm looking forward to October 30th with bated breath. We just had this weekend, we went through the whole series, Mandalorian series, just to rewatch it in anticipation of the new season. So yes, Disney did not screw that one up. They did screw up Rise of Skywalker. Why did they even kiss? Why did they kiss? What was up with that? That even need to happen? No. Okay. Palpatine, he was already dead. He's already dead. Yeah, the whole thing was a cash grab. That's all it was. It was one big cash grab. Like, come on. What's wrong with you people? So sad. So sad. Anyway. Okay, enough of that. Let's go back to this guy here. Okay, so we had red. How many reds do we have? We had there you go. Okay, so we have 5 will be our vertical axis. That's how many we have. So 1, 2, 3, 4, 5. Okay, those will be our frequencies, right? Our frequencies. And then we'll get rid of the sun here. Okay, and then we want to have our bars. Okay, so I'm going to put little marks here. Okay, and these are going to be where our bars go. Now, our bars in a bar graph, they do not touch. So the bars do not touch. Okay, they do not touch. Okay, in a bar graph. Now we're going to talk about something called a histogram where they do touch. Okay, but right now the bars, if it is categorical data, the bars do not touch. Okay. I'll put 4 categories. If it's numerical data, then they do touch. But if it's categorical data, they do not touch. Okay. Okay, so what was the first bar? Well, the first bar would be blue at 5, right? So blue 5. Blue 5. Okay, boom. And I'm going to put a little 5 up here at the very top to tell me, look, that's how high, that's how many blues I had. Okay, and then the next one was green, right? And green, we didn't go up as high. We went up to 4 for green. Okay, oops. Okay, so 4 for green. And once again, the bars do not touch, but we're going to get 4 for green here. 4 for green. Okay, and then for this one, we're going to do 5 for red, right? 5 for red. Okay. Okay, so that's 5 for red. Okay, 5 for red. Okay, a Pareto chart. Okay, a Pareto chart is a graph ordered from highest to lowest. Okay, highest to lowest. That's a Pareto chart. So if I want to change this chart into a Pareto chart, okay, this is how I would do it. Okay, I would go 5, 5, 4. Okay, I would go blue. Let me write this down here. This is blue. This is green. and this is red. Okay. And if I wanted to put this in order from highest to lowest, I could put either the red or the blue first. It doesn't matter. Okay. Okay, I'll just go with blue first in this case. Oops. I'm just going to put them all in black so I can do this quick. So 1, 2, 3, 4, 5. Like so. And that's going to be blue, 5. This is going to be red, 5, like from Star Wars. Okay. This is red leader, red 5. Okay, and then green, right? Green, 4. Okay, green. Okay. So again, you can color code them if you want to. I don't have time to do that. Okay. So this is called a Pareto chart. Okay, Pareto, you can think of it as a Pareto bar chart. Okay, where the bars are listed in order. From highest to lowest. Okay, other types of graphs representing data. Okay, so create a pie chart of the colors given in 9.1. Okay, so let's look at a pie chart. We usually want to work with percentages. Pi equals percentages. And we already calculated the percentages. Okay, what was it? It was, the blue was, I think it was like 35.7. Is that right? Let's see what this is. Yep. And 28.6, right? So the blue is 35.7. The green was 28.6, and the red was 35.7. Okay, so it's about a third each, right? It's about a third. So when I want to do basically thirds, when I want to represent thirds, I create what's called a kind of that P symbol. Okay, so right, so thirds is going to be kind of like this. Okay, actually it's not. Like this, I guess. My circle is not too good. Let me draw my circle a little bit better. There we go. So the P sign I think goes down, but I'm just gonna cut this thing in thirds here. Okay, that's a little bit better. Okay, so thirds. The smaller one I'm gonna make the green guy. Okay, so this is green. Okay, the other two, which are kind of split in half, are going to be red and blue. Okay, so red and blue. And that's a pie chart. Okay, I'm sure you guys have seen this back in 7th grade. Okay, this is a kind of a 7th grade standard. Okay, but it's just good. It's good to review. Okay. Okay, another type of chart is called a pictogram. It says a labor union might produce a graph to show the difference between the average manager salary and the average worker salary. Okay. And so what do we notice about the manager salary versus the worker salary? Well, you know, the height here is about twice as high, right? So this thing is about it's kind of confusing. Pictographs are confusing, right? The worker needs to work harder. I don't know. It depends on the makeup of the company, I guess. So worker needs to go to college, maybe. I don't know. Okay, education, it helps. It's not a magic, like it's not a magic bullet. You know, education doesn't always mean that you're gonna make a ton of money. Okay, and it just means that you might have a better quality of life too. Do something that you enjoy doing instead of something that you're forced to do, right? So, but it's better to be educated than non-educated. I would assure. So worker salaries. Now, the question is the manager's salary twice as much or 4 times as much? Or 4 times as much. And why would I say 4 times as much? Because the area here, if you think of the area, this is that bag is about 4 times the area of the other one. However, it's only twice as tall and twice as wide, right? So twice as tall and twice as wide, right? So like,
Professor, I think you're muted.
okay, sorry about that. Whoa. Okay, testing 1, 2, testing. Testing 1, 2, testing. Looks good. Finished. Okay, perfect. Okay, so again, I was saying, is the manager's salary twice as much or 4 times as much? We don't know. We just know that it is more. Okay, my writing is awful here. Let me turn this into something smaller. Okay, we just know it is more. Okay, it's more. Okay, so enough of the pictogram. Okay, misleading graphs. Misleading graphs. Some graphs are intentionally misleading. Imagine that. Somebody would want to mislead you with statistics. Okay, there's Mark Twain said, okay, this is Mark Twain. He said, there's truth, there's lies, and then there's statistics. Okay, which basically says, is it true? Is it false? Okay, imagine that they would mislead you, right? They would mislead you. I saw this being misled driving down the freeway the other day. They were misleading me with statistics. They said that this diet soda, right? This diet soda that was being advertised, they said our soda has half the calories of the other leading brand. Okay, other leading brand. Our soda has half the calories of the other leading brand. Well, that seems to be a little misleading. What if in a 12-ounce soda, that soda had, I don't know, 2 calories? But the other leading brand had 4 calories. Do those 2 calories really matter that much? Right? Why would you stake your whole advertising campaign on 2 calories? Right? When normally people eat around 2,000 calories a day. So was that a misleading statistic? Yes, absolutely. You're saying, oh, well, you know, Coke Zero has 2 calories, but Pepsi, you know, has 4 calories. And you're like, well, we've got half the calories. You're thinking, Okay, well, that's great, but there's misleading statistics in advertising all the time. Does that make sense? Okay, can you see the inaccuracy in the wedges here? Say that this was a chart that was on you know, a billboard being advertised and saying, oh yeah, you know, what's misleading about this chart? Well, the percentages and the colors, they don't match up, right? They don't match up to the shape. The shape and the percentages don't match up, right? Look at what 25% is here versus 25% here. They're not the same, right? They're not the same, right? All the 25s, all 25% should be what? They should be 1/4 of the circle, right? But they're not. They're not. And what about this guy here? Look at magenta. Magenta is 3% of the graph. That should not be looking like it's, you know, I don't know what that would be. That would be like 20% of the graph, right? That should be just this tiny sliver. Should just be a tiny, tiny sliver here, 3%. But it's not. It's like 20%. It's represented way too big. So misleading. Okay, very misleading. Very misleading. Okay, what about this one? The figure below. Okay, the figure below. Oh, and what's the other misleading thing here? Is that these don't add up to 100%. Okay, misleading, and they do not sum to 100% either. Okay, if you were to add all these up, you would not get to 100%. So the graph is just totally off. Okay, the figure below displays the SAT scores of 3 students, but each chart looks different. The 2 charts have the same data, but the difference seems larger for the graph on the left. Why? Okay, what's the difference here? Well, the difference is the scale. The scale is the difference. Okay, this one goes up to a scale of 2400, 0 to 2400. So you're focused more on the entire graphs here. Okay, this one goes from 0 to 4000. So half of the graph doesn't contain any information, and so it makes the difference in the bars look smaller than it actually is. Okay, it's misleading. This is visually misleading. Okay, so another thing that they'll do is they'll do this. They'll go like this. Let me show you this. This is extremely misleading when they do this. Go, oh, here's your bar, right? And then here's another bar. Okay, color these in. Okay, and then they'll say, oh, this is 3600, this is 4200, this is 4800. And what's the problem with this? What's the problem? This is 4200, this would be 5400, right? And then maybe 6000. What's the problem with this one? Any ideas? The distance between the values is 600, but the distance between the bottom of the graph is 3600. It's 6 times as much, right? And what they'll do is they'll put a little thing here and they'll do, oh, well, there's a break in the scale, right? There's a break in the scale, which if you were to look at this thing where the scale didn't have a break, like this is a break in the scale. Okay, you would see that the difference between these two really isn't that much. But they'll do this break in the scale thing, and then it'll say, oh, and then it'll make the difference here between these two more pronounced, right? I mean, if you want to really get way pronounced, you would do something like this, right? And you'd be like, oh, this is at, 10,000, and this is at 10,001, and this is at 10,002, and you're like thinking, wait a second. I'm going all the way up to 10,000. This is not very that 4 or 5 units is not going to be much different, right? I don't know. So this is 0, 1, 2, 3. We'll make this 3, 4, and 5, right? So the difference here is 5 units. But you get the idea, right? You see how that the difference is way exaggerated, right? Is the difference between 10,000 and 10,005 that much? Okay. And so they do a break in the scale here. They do this little break in the scale. It's called a break in the scale. Oops. They do this break in the scale. Breaking my tablet is what I'm doing. Okay, there's a break in the scale, and they're like, oh, well, see, the difference here is it's visually, again, this is visually misleading. Visually misleading. Okay. Does that make sense? Make sense how this is visually misleading? I hope that makes sense. Okay. Let's talk about quantitative data. Let's talk about quantitative data. That's numerical data, okay? How do we represent numerical data? And we do it using something called a histogram, okay? A frequency table, which we've done before, but now we're going to do a histogram and not a bar chart. Because numerical data we can actually put in order, okay? We can put numerical data in sequential order. You can put this in order, right? So we know that 5 comes after 1. We know that 110 comes after 100. Oh, okay. Okay, so let's construct a frequency table, and let's include the relative frequencies here. Okay, let's do a frequency table. Okay, so this is for where 16 randomly selected weights. Okay, 16 randomly selected weights here. Okay, and so I want to make a table out of this. So weight, frequency, and I'll put relative frequency. Okay, weight, frequency. So I want to start with the lowest one here, and the lowest one is 85. Okay, so we've got 85, 85, 85, and 85. Okay, so we've got 4 of those 85s. Okay, the next one is 98. So we've got 2 98s, 2 of those. I've got 100, which is right there. I've got 100, so 1 of those. And then 110. Okay, 110, I've got 1, 2, 3, 4 of those. 4 110s. And then 115. 115, I've got 1, 2, 3 of those. And then 138, I've got 2 of those, I believe. Yep, 2 of those. Okay, so if we were to add all this up, 4 plus 2 plus 1 plus 4 plus 3 plus 2, what does that add up to? 4 plus 2 plus 1 plus 4 plus 2 plus 3 plus 2. What are going to be my denominators here? Well, let's see. We've got 4 and 4 is 8, plus 2 is 10, plus 1 is 11, plus 3 is 14, plus 2 is 16. So I'm going to say that it's 16 out of 16. So this is going to be out of 16. Make this a little thinner so I can write a little smaller. Okay, so 4 out of 16, 2 out of 16, 1 out of 16, 4 out of 16, 3 out of 16, and 2 out of 16. Okay. Okay, so this is 1/4. This is 1/8. This is 1/16. This is 1/4. This is 3/16, and this is 1/8. And so 1/4 is 0.25, so I know that's 25%. 1/8 is half of that, so that's 12.5%. 1/16 is half of that, which is 6.25%. 1/4 is 25%. 3/16, that's going to be 1/16 plus 1/8, which is 18.7, or sorry, 18 point, should it be 7.5? 2.5. What's 3 divided by 16? Yeah, 7.5. 18.75. Percent, and then 1/8 again is 12.5%, right? Okay, and if we were to add all this up, hopefully it would come out to 100%. Okay, so those are my relative frequencies. Okay, what's a histogram? A histogram is similar to a bar chart, but for quantitative data. Histograms have a horizontal and vertical axis, whereas the horizontal axis lists the values in the frequency table, and the vertical axis lists the frequencies. The rectangular bars are touching the adjacent bars, okay? So in a histogram, the bars do touch. Construct a histogram from the data's model's weights in example 9.8. Okay, so we're gonna do a histogram here. So we know the weights go from what? We go from about 85 to 138. Okay, so 85 to 138. So I'm gonna start at 80 and go up by tens. 90, 100, 110, 120, 130, 140. Okay, so now I need to kind of group these. Okay, in these, what we call these are bins. Okay, we're going to say that our bin width is equal to 10. Okay, our bin width is equal to 10. Okay, what's a bin width? The bin width is the distance or the difference between bars. It's the difference between bars. I'm going to have a bar from 80 to 90, but then I'm going to have a bar from 90 to 100. And what's the difference between those bars? The distance between the start of one bar and the start of the other bar is going to be my bins. Okay, so what are my bins here? My bins go from 80 to 90, but 90 is not included. So I put a parenthesis, okay, in my interval. This is called interval notation. Okay, so for how many are between 80 and 90? How many pieces of data were between 80 and 90? How many pieces of data were between 80 and 90 here? Between 80 and 90. Well, how about 4, right? Isn't it 4? Yeah, exactly. Thank you, Lainey. It's 4 because 85 I had 4 at 85, which, so if I go up here to 1, 2, 3, 4, right? I'm going to put a bar, and it's going to go all the way to 4 from 80 to 90. Okay, 90 is not included. But everything between 80 and 89.99999 is included. So 85 is represented 4 times. And so the data that falls between 80 and 90 goes in here, goes in that bar, that part of my histogram. Okay, what about 90 to 100? Okay, well, how many of those did I have? Well, I have 2 98s, which fall between 90 and 100, so that's going to be 2. Okay, and I might do that on the top. So 90 to 100 is 2. Boom. Okay, what about 100 to 110? 100 to 110. Is it 1 or is it 5? Is it 1 or is it 5? Is 110 included in this bar or the next one? Yes, thank you, Lainey. It is the next one. Perfect. Okay, it's the next one. Why? Because that would be the start of the next one. And what we call this is a right hand. Oh, sorry, this is a left hand. This is a left hand histogram. Meaning that we start on the left of the divisions. The left takes prominence. Okay, so 80 is included, but 90 is not. 90 is included in the second one, but 100 is not. Okay, so this is just going to go up to 1. Okay, so that has 1. Now 110 to 115. Ooh. 110 to 120, that's going to be 7. Wow, okay. I didn't draw this. I didn't anticipate it going up to 7. 5, 6, 7. I'm going to make 7 right here. Okay, there's 6. There's 5. Okay, so now we got to go way up, right? Because these two, those two are included between 110 and 120. So that's 7. Okay, so whoosh, all the way up there. And then whoosh. Do the whoosh. The whoosh makes it more exciting. Whoosh. Okay, and the whoosh. Oops, I can't draw a straight line. Whoosh. There we go. Okay. Okay, and so this goes up to what? This goes up to 7 now. 7. 7 from there. Okay. Okay, what about 120 to 130? Nothing. There's nothing there. So I'm gonna kind of highlight the fact that there is nothing here. So this is 0. Okay, the top of the thing is actually on the line. There is no bar there. Okay, 0. And then what's the last one here? 138 goes up to any numbers between 130 and 140. Okay. Not including 140, that's 2, right? And that's my histogram. Okay, that's my histogram. Okay, it's a pretty nice histogram. I like it. Okay, so the bin width here was 10, right? The bin width there was 10. Now, how did I get the bin width of 10? Well, generally we want our bins to be anywhere from, say, 5 to 10. Okay, 5 to 10 bins is nice. Okay, so what I did was I said, well, I have 138, which is close to 140, minus 85, which is close to 80. And I said, well, if I take this is 60, and I divide by 10, I get about 6 bins. Does that make sense? I said, hey, you know what? Let's make this about 6 bins. Okay, and each bin can be 10 apiece, right? Giving me a total distance of 60. So that's kind of what I did in my head there. I was like, hey, going from 80 to 140 about, in that ballpark. Okay, now there is a more formal definition, which I don't often use, but it's there. Okay, so it says class intervals, which are called bins. They call it class intervals. Class intervals are just bins. Okay, they're called bins. Okay, class intervals. Class intervals are used for organizing data, usually for large data sets. In general, class intervals usually have somewhere between 5 and 10 classes. I'm going to say 5 to 20. I'm going to say 5 to 10, depending upon the number of data. Okay, are equal in size. Okay, your class intervals or bins will always be equal in size. The difference between upper and lower class limit is the same. For example, if the first interval is 120 to 129, then notice that 120 to 129 is 9. Hence, the next interval is required to be 130 to 139. Okay. And that's kind of like if you're dealing with whole number data. So the interval size is the same as the others, and the difference between upper and lower limits is 9. They will contain all data in the set. Okay, subtract the smallest value in the set from the largest value. This is your range. Okay, divide the range by the number of class intervals desired. So I took the range to be about 60 in the last one. The range was 60. And I said, I want, somewhere between 5 and 10. 6 goes in nicely to 60. And so my width, my bin width, or what's called my class range, this is also my bin width. You'll see it both ways. Okay, the bin width or the class range, okay, in my case was 10, right? Because the range, okay, was 60 divided by the number of intervals I wanted. Okay, I'll just put number of bins. I'm just so used to using bins, but this author doesn't use the word bins for whatever reason. When you take stats, if you want to take stats with me next semester, we'll call it bins because that author uses bins. Doesn't use class range. Okay, but different authors use different terminology. Okay, I've been teaching this stuff for a long time, and I've seen it called a lot of different things. Okay, but we'll just go with what the author goes with, and that's class range. The homework, it might ask you for the bin width though, so we'll see what happens. Okay, for example, example 910. Okay, the total cost of textbooks for the term was collected from 36 students. Create a frequency table with 8 class intervals. 8 class intervals. Okay. Then construct a histogram for this data. Okay. So what's the highest value here? 460. They have the data in order, which is really nice. Okay, this is called ascending order. Okay, which is really nice. We were going to need to put it in ascending order. Okay, ascending, right, means to go upstairs. Like if you ascend stairs, right, to go upstairs, right? So I know the language is hard to the terminology sometimes is the hardest part of learning a new subject, right? Ascending order, going up the stairs is to ascend, right? We start at the lowest and we go to the highest. Okay, well, what's 460 divided by, or what's 460 minus 140? 460 minus 140. Okay, and how many bins do they want? They want, how many intervals do they want? They want 8 intervals, right? So we're going to divide that by 8. Okay, so what is this end up? This is 320, is that right? 320 over 8. So we're going to have 40 as our interval. Yeah, 40 is going to be our interval. Okay, so let's see what we got here. So I'm going to start at 140, and I'm going to go to 180. Okay, I'm going to go to 180. So I'm going to add 40, right? I want the widths to be 40. So I'm going to go to, I'm going to do this, okay? I'm going to go 140 to 180, okay? What's the midpoint of that? What's the midpoint of that? The midpoint of that is 160. Okay. What, we're going to use that in a minute here. Okay. 160. Okay. And then what about the next one, which is 180 to, what is this, 220? We're adding 40 each time. The midpoint is always going to be 20 more, so that's 200. Okay, and then 220 to 260, I believe, with 240 as my midpoint. And then to 300. Okay, and then that's going to be 280 is my midpoint. And then 300 to 340. Okay. And that's going to be 320 is my midpoint. Okay, and then 340 to 380 with 360 as my midpoint. And then 380 to 420 with, okay, 420 with, what is it? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. This is going to be interesting though, because I'm actually going to end up with 9 bins, but we'll discuss that in a second. It says they want 8 bins though. 8 class. I don't know. We'll see. We'll see what happens here. Okay, so 360. Okay, so this is going to be 400. Okay, and then I'm going to go 420 to 460, but 460 is not included. 440 is my midpoint there. Okay. In order to get these 460s, I would either have to add another bin or I'd have to adjust my bins up by one unit. Okay, instead of having my bins be 40, I would have to have them be 41 to include 460. So let's do that. Let's adjust them so that they go by 41. Okay, because they only want 8 of them in this case, and I would have to leave off those last 2 data points. So let's go by 41. So this would be 181. Okay, this would be 181 to 222. Okay, this would be 222. I'm just going to add 1 to each of them. To 263, right? 263. Okay, and then 263 to 304. Okay, and then 304 to 345. 345, I believe. And 41, yep. 345. 345 to 386. Okay, 386 to 427. Okay, and then 427 to 468. There we go, 468. Now I have each of them included. Okay, so what's my midpoint going to be? My midpoint is going to be, instead of 41, instead of 20 in between here, okay, it's going to be 41 divided by 2. That's going to be my midpoint, which is going to be 20.5. Okay, so this is going to be, so I would have to add a 0.5 to this guy. So that's 160.5. Okay, and then 181 to 220, I would have to add 1.5. This is 201.5. And I'm going to have to add a 1 and a 0.5. Keep adding the 1 and a 0.5. So this is going to be, instead of 240, it would be 242.5. Is that right? Think about this for a second. Yep, 242.5. So again, yeah, just keep adding a 1.5 to that. And that's going to be a 283.5. This is going to be 324.5. And this is going to be 365.5. And this is going to be 406.5. Okay, and this is going to be 447.5. There we go. Okay, those are the midpoints. So now, how many are in each of these? Each of these bins. How many are in each of these bins? Okay, so we want to know how many are between 140 and 180, right? With 181 would be the next bin. So I've got 140, 160, 160, 165, 180. Okay, so we've got 5 in the first bin. Okay, 5 in the first bin. Okay, we cross those off. We've already used those. Okay, what about the next one here? 181 to 222. I've got 220. Oh, it's just 1. Okay, 235 is too big. What about 222 to 263? Well, I've got 235, 240, 250, 260. So that's what? 1, 2, 3, 4, 5 again. 5, okay. 280 or 220, or sorry, 260 to 304, 263 to 304. So 280, 285, 285, 285, 290. We're going all the way up to 304, right? 304, 300, 300. Okay, so we've got 1, 2, 3, 4, 5, 6, 7. Looks like that's 7. Okay. 305 is in the next one, right? That's in the next one. 304 to 345. 305, 310, 310, 315, 315, 320, 320, 330, 340. 345 is actually in the next bin. It's in this bin here. So we're going to say, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 345 to 386. 345 to 386. 1, 2, 3, 4, 5, 6. Boom. Okay, what about 386 to 427? 386 to 427 looks like it's these two. 395 and 420. 2. Cross those off. And then 427 to 468. Oh, that's these last two that I wanted. And so that's 2. Okay, so now we're going to draw our histogram. Okay, with bins or class intervals of 41, right? So we want 8. Is this 8 here? Is this 1, 2, 3, 4, 5, 6, 7, 8? No, this is 9. 2, 3, 4, 5, 6, 7, 8. That's fine. Okay, so it just depends on where you want to start. Okay, so I'm going to start with 140 here. This is 181. This is 222. This is 263. This is 304. This is 345. This is 386, and this is 427. And this is 468 will be the last one here, 468. Okay. And so so we want to know, well, what's the frequency here? Well, the frequency in the first bin is 5. So 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's good. Okay, so the first bin is going to go up to 5. So we're going to draw our first bin. Okay, first class interval, our first bar in our histogram is going to go up to 5. Okay. make this a little thicker so I can write a little nicer. Okay, what about the next one? The next one goes up to 1. Okay, our next bin. The next one is 5. Back to 5. Okay, the next one is 7. Up to 7. The next one is 9. Up to 9. The next one is 6. 6. Okay, the next one is 2. 2. The next one is, or the last one here is 2. Okay, and so there's our histogram. Nice histogram. Okay, it has 8 bin widths. Or sorry, it has 8 bins, each of width 41. Okay, each of width 41. Okay, so now we're gonna do what's called an ogive graph, and that is a line graph based on these midpoints. Okay, this will be the last thing we do today, is the line graph based on the midpoints of these. Basically, we're going to take the midpoints here, and we're just going to connect the dots of the midpoints. That's it. Okay, and so what would this look like if we connected the dots of the midpoints of the bars here? Well, it would look like this. Okay. Actually, an ogive is a cumulative frequency, sorry. This is just this guy here, it looks like this. Okay, so the red guy here is the graph of the midpoints as a line. And that's, oh, it's called a frequency polygon. This is called a frequency polygon. Okay, a frequency polygon. And we could recreate that here. They wanted us to recreate this here. Okay, down below, okay, for the frequency polygon, right, the frequency polygon here, okay, and I don't know if they're giving us the midpoints or what here. I think they're giving us the midpoints, right, 365, yeah, they're giving us the midpoints, and they want to know at these midpoints, you know, what's the frequency polygon going to look like, and I just drew it there, but at 160, we're at 5. Okay, at 160, we're at 5, and then at 201, we're at 1, right? 1, and then 242, we're at 5. 242, we're at 5, and then 7 is 283, okay, and then 9 is next, and then 6, okay, 324, and then 365, we're at 6, right, oops. Okay, and then at 406, we're at 2. And then at 447, we're at 2. Okay, so, and then we're just connect the dots. Okay, and this is my frequency polygon. Okay? Okay, that's it for me today. If you have any questions about anything, please let me know. I hope that my explanation at the beginning about, are you up to college level math? You know, there's a couple of thoughts in education, and that's if all students cannot reach the bar, right? Say you're supposed to jump over this bar. If students can't reach the bar, then maybe we should just lower the bar so that everybody can jump over. I don't really subscribe to that notion, okay? Because I want things like this, okay? Like this guy here, he's like extremely important to me. And I want people in our society to be able to make stuff like this. Okay, so if I lower the bar for everyone, then nobody's gonna be able to do their jobs. Okay, so that's one theory, is we'll just lower the bar for everyone. And I think that secondary education has really subscribed to this notion, right? Or how about this? How about if we want people to jump this high, that we start them off higher. And they can jump off higher. Okay, well, that just means that we're going to nerf our problems and give you all the extra stuff in the beginning. How about this though? How about we do more jumps, and the more jumps you do, what's going to happen? The stronger you become. Oh, look at that. See, this is what I subscribe to. These theories, I don't subscribe to. I'm sorry. Don't lower the bar. You don't make it easier for students to begin with. You work with them at creating more and more jumps, but it takes time. It takes a lot of time. Okay, and a lot of people aren't willing to do this. Okay, that's why there's not a lot of engineers and scientists and people like Elon Musk out there who are willing to work 7 days a week, 160 hours a week to make their dreams come true, because they don't want to do this. This is too hard. Okay, that's too much work. Right? Again, it all depends on, nobody's going to make you work at Walmart the rest of your life. Right? Nobody's going to make you work at Walmart the rest of your life. Nobody's going to stick a gun to your head and make you work at Walmart. And nobody's going to stick a gun to your head and make you work at JPL or NASA either. It is entirely up to you. It is entirely up to your choices in life. It depends on how hard you want to work and what you want out of this life. Okay? The choice is yours to do whatever you want. So hopefully you choose your path. And not anyone's path is necessarily better than another's. It just has different rewards and different consequences. So with that, I will bid you guys adieu, and I will see you on Wednesday. Okay?
Thank you, Professor. Take care.
You're welcome. Thank you for being in my class.
Okay. Let's hope for that Mandalorian coming soon.
Exactly.